an example of repetitive activities. So our whole idea here is so we talked about how we can basically optimize it if we have limited resources. We talked about how we can actually optimize it if we have, let's say, some overhead that we want to reduce as much as possible with respect to the duration, but we don't have any, let's say, constraints for the resources that we're utilizing on a particular time during that project. Now we're going to be talking about, okay, how can we actually utilize our flow of activities in order to be able to basically capitalize on that and optimize for flow, which that by itself also reduces the duration as well, as long as we have activities that are repetitive and those activities can actually continue going forward and forward and forward. Okay, so as an example, I'm talking about here a construction site where as the construction site goes forward, we're basically having some progress there. And there are some activities that are carried out for this particular construction site that are going to be completely the same, right? So dependent upon the type of repetition and the type of divisions that we might have, we're going to have some activities that are going to be carried out that are going to be exactly the same, that are repetitive. Some of these activities can actually be carried out one after the other for every unit that you're going to be having. Essentially, we can sometimes, instead of having this, let's say, all of these activities for the first floor, all of these activities for the second floor, all of these activities for the third floor, or for the third division or fourth division, we can actually recalibrate these and reorient them so that we can actually optimize for continuity. So how does that look like? It looks something like this, and this is not always possible, but there are some tricks that we can do dependent upon how we're going to be doing the subdivision that we can actually optimize for the flow as well. But for this, we're just talking about some simple examples that we can do, let's say linear construction. This could be highway, this could be buildings that are going to go up. So the activities can actually go one after the other, and we can actually continue them as well if we reorient them. What does that mean? That looks something like this. If we have activities A, B, and C, where activity B is, let's say successor of A, and activity C is a successor of B with some, let's say, overlap there, and then one after the other for different types of units. This could be, let's say, if you have a huge, let's say, urban planning project of some sort, or let's say a housing project that you have multiple different housings of similar characteristics that are going to be built by multiple different crews. You can actually create that subdivision based on every house, for instance, or activities that need to be carried out for every house, and that would be one unit, okay? That would be the simplest example. But that's what that could happen, is that can actually be reorientated so that activities A could all be carried out together, okay? So activity A for the first unit, for the second unit, for the third unit, and it's going to create a flow there. And activity B with some buffer can actually be carried out as well, one after the other, and activity C. So right now, we've basically changed and shifted from the left-hand side, which is our typical A, basically after, before B, before C. This now has actually shifted into every A for all of the units can actually be carried out together. This by itself also has the benefit that we do not need to hire and, let's say, fire these particular or lay off these particular crew members for each and every one of these activities for that particular unit. That can actually be carried out. And it's shown that that can actually do and improve what we call learning curves. Do you guys know that as well? The more you basically do an activity, the more chances you're going to be having to have a better productivity for that particular activity as well. So this by itself means that that particular crew or a bunch of crews that are going to be hired for, let's say, concrete, are going to always be hired for concrete throughout the duration of all of the, let's say, 10, 20, or whatever many units that you're going to be having, okay? Okay, so how do we basically solve this? One example of this, I'm sure all of you have seen this, Do you know what the scheduling plan for this? What is this building? This is the Empire State Building, right? If you took a look at actually the construction plans and what they were able to do, essentially all of these units that you're going to be seeing for that subdivision. So this time the subdivision are going to be for each and every one of the stories, right? And that by itself is going to be one units that you're going to be carried out and different activities that you're going to be having for each and every one of them. This by itself is completely linear or close to linear. And they're more or less very, very parallel together as well, which is the absolute optimized version of these as well. Essentially, with some buffer, we would be able to start the other activity and the other activity. So this is how we can actually optimize for the flow, as long as we have a good unit of division that we find, and we would be able to know the production rates, and hopefully if we can actually parallelize these production rates in terms of optimization, that would be the best possible solution. And then using that, we would be able to optimize the whole duration of the project as well for different levels that are going to be carried out. Hopefully, especially for repetitive activities, is going to be fantastic. This is an example of what we call a linear construction, right? Linear construction, in this case, if our subdivisions are stories, that would be basically the linear construction that we're going to be having. Same with highways, right? Highways are going to be linear construction per basically meter or per kilometer or per unit of length that is going to be carried out and constructed. That is going to essentially provide us with a unit, right? And that is going to be the discussion that we're going to be having. Nowadays, we can actually even do the subdivisions in terms of every floor plan as well, and we can divide them as well. And that's going to be more or less what we call location-based planning. This is going to be basically linear planning that we're going to be talking about. And line of balancing is a particular type of linear scheduling that I'm going to be talking about, which only tries and attempts to optimize for flow of repetitive activities, okay? So how can we do this? How can we basically look at this? So we have these activities. We have to know what we call a slope, which is flow rates, or sometimes it's referred to as production rate as well, depends upon how it is. Essentially what this is the slope. How many units are going to be carried out and how much time? Okay, that's basically that line that you're going to be seeing there, okay? Using that and using basically the next one, we would have to see whether we have to add a buffer from the top or the bottom. Why do we have to add the buffer in general? Because if, let's say, you're going to have a production rate that is going to be this, and you have a production rate that is slanted, okay? If we basically put a buffer from the top, these two are going to be interfering with each other, right? We don't want that to happen, because every one of the units of activity B is going to be carried out after the finish of every unit of activity A. That is the rule that we have, right? So if our successor has a smaller production rate, that means that basically the slope is more slanted. We have to add a particular buffer to minimize any type of interruptions and to make sure that the rules that we have is going to be satisfied, because activity B for every unit has to be completed after, or have to be started after the finish of activity A. Then we have to do it in this way. And this is going to be how it is. Vice versa, if now we have, let's say, a production rate of an activity that is a bit more straightforward, what do? We add a buffer from the top. This way. This is the simplest way that we would be able to do it. A fully optimized, let's say, flow would be all of these being parallel together. Why would this be optimized? Imagine A and C having the same flow rate, okay? B here has a lower flow rate. What would be the best possible solution? If B also has the same flow rate there, right? This way, it would basically reduce, okay? For every flow rate that you're going to be having, the minimum of that would be basically the best way. And if you can actually make sure that all of these flow rates are the exact same parallel together, that would essentially be the optimum solution that you're going to be having. So that is basically the art here. How do we basically play around with it so that we can make that happen? Essentially, any one of these activities, so the kind of precursor to that would be any activity whose production rate or that flow rate is actually slanted or has a slower slope, that is going to be our critical activity. That is the activity that we need to be able to pay attention to, right? Yeah, because that is what is predicting our schedule or our inefficiencies in our schedules. Make sense? Yeah, okay. Fantastic.